The same. Question 3. Look, the student uses a pendulum to determine, this is question 3. I will share this file with you after the session, so you can also practice the remaining question, okay? The student uses a pendulum to determine the acceleration of a free fall, because the first what we did about how to plan experiment. Now, sometime in a questions, you will have to write the values as well. So student is using a pendulum to determine a value of acceleration of a free fall. In paper 6, you don't have to memorize any formula. Any formula is there, they will provide you. So you don't have to memorize anything in paper 6. For paper 6. ATP, no formula, you don't have to memorize anything. Everything they will provide it. No, like how to get the time period, that is a basic thing, like, yes. Next is on a figure 1.1, measure the length of the pendulum. How we can measure the length of pendulum?
From the beginning of the plate to the center of the
No, on a figure, look, in the question they mention on a figure measure. Yes. So what you will do?
Sir, we will on the base we will
measure. The scale which you will.
Yeah.
So what you will do, not meter in exam, not meter rule. Like meter rule is, you will have your ruler, just place a scale beside and measure this length.
Okay, then.
So what is this length example if it is? So let's say you measure this length, it is 2.1. So you'll write 2.1.
Then.
If it is 5, you'll write 5. Any number you can according to the length, okay?
So what if there is like a slight error? Maybe 2.1 and make it 2.
If it is within 10%, yes, they will give right. But for these questions, exact answer is there. Yeah, it will. No,
what we will do after
it should be exact because you have to place a ruler here. Like
even in the above,
yeah.
measure the
They mention this point, like they mention the starting and the final point, so you just have to place.
Maybe say 2, 3, 4 centimeters or then.
The next is a student adjusted the pendulum length is 50 now. The length is measured to the center. Explain how the student avoid a parallax error. How student can avoid a parallax error? Yeah, so mention look perpendicular and look look perpendicular. Place a ruler next closer to the pendulum. Okay. Use set square. What is a set square? The triangles you have in your geometry box, that is a set square.
Yeah.
So
But sir, I don't have
that is another thing. So the geometry box, and then you look perpendicular. You will mention look perpendicular, but I'm saying how effectively it can be done. Practically, it can be done. So when you have a pendulum, you will place a meter rule, a scale close to the pendulum. Use a set square, the position where there's a center of the pendulum, and look perpendicular. Okay.
Open eyes.
So can you write that down?
Yes, I'm writing it, but I'm explaining on the diagram. So how student avoid a parallax error when measuring a length? So first, the student should place the ruler next to pendulum with set square. And look perpendicular. Yes, by viewing at the eye level or looking perpendicular, but explain briefly. So that is like placing a ruler next to, and then placing a set square and then looking at perpendicular. That will be more accurate. Is it clear? Anas, Ahmad, Saim, Iman?
Yes, sir, clear.
Perpendicular.
Yeah.
So what do you mean by set square?
Set square is a aid which you use in a geometry. So whenever like levels are there, surfaces are not exactly straight, plane, we use a set square. Yeah, this is a set square. The next,
सर आपके लिए फॉर्मूला नहीं आज करना इसमें फॉर्मूला
okay, the student displaces the pendulum. The student displaces the pendulum and release. He measured a time for 20 complete oscillations. The time for 20 oscillation is 27.8. You need the period. How to get the period?
Total time divided by number of
So 27.8 divided by
20.
20. What's the answer here? The number of the significant figure is also important. So you have like that was in 3 significant figures. So this should also be in 3 significant figure. 27.8 divided by 20. Yes, Rafi.
Yes, sir, yes, sir.
27.8.
39.
Wrong.
Sir,
So
1.39, sir.
Right.
Sir, 20 guys. Sir, 20 guys.
1.39 seconds.
Sir, what are you doing, sir?
1.39 seconds. Is it clear how we got this?
Yes, that's very
That's a time for 20 oscillations. Okay.
So this will by default it's written now the time.
Filter होके मेरे पास है ना, मेरा हुआ.
By default the time is written over here.
यार, आप लोगों का बच गया.
Yeah. This is there. That's in the question. The next is measuring the time for large number of oscillation rather than one is more accurate. Okay. As we just discussed, like if you record a time for 20 oscillation, it will be more accurate as compared to time for one oscillation. The question is, suggest one practical reason why measuring a time for 200 oscillation rather than 20 oscillation may not be suitable.
It requires more time.
It may stop
No, it required more time means it will be accurate. Yeah, it may stop vibrating. Like practical rotating. No, it is an oscillation, simple harmonic motion. It's called
rotating
the pendulum not rotating. Pendulum is vibrating to and fro. Pendulum you release here. See, it will go to one side and then come back. What do you call this? Rotation, vibration.
Rotation.
Yeah, so oscillation. So practical reason, so you can say you may miss the count.
Which one?
Count. Yes.
You may miss the count for oscillation, or the pendulum may stop before, might stop before completing the 200.
So write the second reason as well.
एक बार के भाई कौन से वो 10 मार्क दे देंगे
एक हुई या तो फिर क्या होगा उससे याद है
ये भी सही Sir, why you are writing two times? They are giving just 1 mark.
No, he's saying he'll remember the second point. That's both points in case if you forgot.
So I will write
No, if you say there is more chance of error, but you have to specify reason. What kind of error is there? And theoretically, 200 is more accurate than 20 because more oscillation means lower lower percentage uncertainty. But practically, it's not possible.
It will take a lot of time, right?
Not it will take a lot of time. You are not counting 1, 2, 3, 4. Stopwatch is there. Because practically what happened, 200, theoretically 200 is more accurate. No, practical. We have to suggest one practical reason. They said theoretically 200 is more accurate. And if you read the first line, that measuring a large number of oscillation gives more accurate result. But why 200 is not an accurate one? Because 200, practically it's not possible. So practical results you will write, like practical things related to the experiment.
The question comes and says, why is it 200?
Yeah, more accurate. Then what you will say, the 200 longer time period, it will have longer time period, so lower percentage error. When you record something long, like example, durations, as a result, what will happen? It will have a smaller percentage uncertainty. The next is T square.
That is square.
So just we have to, what is the meaning of the term T square? Is like we were having 1.339, no, 1.39, T was 1.39. So what is T square?
1.93.
1.39 square. Yeah, like multiply with the same. So what is the answer? 1.93. What is the unit? It is important to write the unit. What is it?
Second.
Wrong.
I said second square.
Second square, because it's T square. So if the unit of the time is second, what is the unit of time square?
Third unit.
Yeah, sir, the unit is written. So-
Where is written?
नहीं मैं कह रहा हूँ सर unit के लिखना है.
No, they will not say like write the unit for everything. You have to write. Yes, you have to write with the unit.
Oscillation.
मैंने कहा मैंने किया तो मेरा लॉजिक के हिसाब से.
Okay, next.
फिर ये कैसे पाएगा?
The next is, listen, boys. The calculate the acceleration of a free fall with the equation. So if you want to calculate acceleration of a free fall, it can be calculated by this formula. So which is G equals to 4 pi square L over T square. Yes. So you just have to substitute the value 4. What is the value of a pi?
3.14 or 22 divided by
3.14 square
Yeah,
multiply by L. What is the length of pendulum?
50
50 centimeters.
50 centimeter, but it should be in meters because the final answer is meter per second
Sir,
square.
0.05
And how you know it's 50 centimeter, as we did this in,
has been stated.
they mentioned that the student adjusted, so the length is 50 now. So that's why we have to use 50, which is 0.5 divided by T square. What was the T square? It was 1.93. When you simplify, what's the answer? 10.1. What? On Earth, you are on Earth, not on any other planet. How?
0.05.
It cannot be 1000. It should be 10. 9.8 is the value of a gravity of Earth.
10.2.
So it should be in the same range. So 10.2. Because theoretically, like the gravity is 9.8, but when you do the experiment, you will not get 9.8 because you have experimental errors out there. So
What's the formula for that?
this is the formula you have to use.
They will give their formula.
Formula.
This
Yes.
formula is eligible for everything, like for this.
Pendulum. Acceleration of a free fall for using a pendulum. This formula is used to find the value of a gravity on the surface of the Earth by using a pendulum. Like on the surface of Earth, we measure the length of pendulum and record how much time it takes to complete the oscillation. So the length of the pendulum and how much time it takes to complete the oscillation, using this formula, we can find what is the value of the gravity. Clear? So you don't have to memorize this formula. It will be given. The next is this. Look, the student checked the value of acceleration of a free fall in the textbook and he found that it is 9.8. Suggests a practical reason why the results obtained from the experiment may be different.
Maybe I have to write and these stopwatch or parallax error and then.
Look, yeah, see,
Sir, so we will vary on this formula, like.
yes, you just go back to the formula.
Then make it different.
Look, the formula is G is equals to 4 pi square L over T square, okay? That is the formula. 4 and pi is a constant thing.
Yeah.
What you are measuring a length and you are measuring a time period or square. So means these are the two things you can do a mistake.
Yeah.
So there might be a mistake in measurement of the length, or there might be a mistake in measurement of the time period. So you can just mention measurement inaccuracy in measurement of the length or
Time.
time. Then how you can improve that?
Be better.
Yeah, could have been error. That's right, while measuring, but you have to specify what parameters can lead to an error. To improvement to the experiment. Whenever you want to improve experiment, what we should do?
Aperture reaction time.
No,
Avoid
like
parallax error.
if you see what is a mistake in this experiment is only one. Yeah, do it multiple times because this experiment is only done once. So what we should do, we should repeat experiment with different lengths.
Avoid
With
parallax
different
error.
lengths.
And what else?
The displacement angle, yeah, with different displacement angles. Mean and.
Proper.
What does that mean?
Repeat experiment. With different lengths. And what else? How we can make a time period accurate? So like in this experiment, we did for 10 oscillation. How it can be accurate?
20 years.
So record a time for
50 to 20 years.
yeah.
It's
Because there was a difficult like measurement of the length was there, so we should measure a length accurately and we should repeat the experiment with different length. We did only for 50 centimeter, but we should do for like 40 centimeter, 60 centimeter, 80 centimeter. And same way, we did only for a time, we only recorded for 10 oscillation. So we should do it for 20 oscillation or more.
अभी ऐसी वजह सीन है ये कहा अभी अपने फिजिक्स पढ़ी थी कहाँ में रिकॉर्ड हो रहा है रिकॉर्ड कार्ड देना कट कर
Yes.
Sir, do you have to copy double the oscillation?
a wait, sir, wait.
Not really double, but it should be higher than the first number. Like you can say 15, you can say 11. No, not significant higher. 11 is like some microsecond difference will be there. So make it like 5 difference, 15, 20, 25, 30. So this was a alternative. Look, two types of question we did, but I want to do the third one as well, in which we plot a graph. No, I'm directly jumping to the graph question. Yeah.
नहीं मुझे तो मजा आ रहा है खासा आर्किटेक्ट
ये क्या होता है मैंने कुछ करा भी नहीं।
Okay.
नहीं, but-
Next is plotting a graph.
है ना?
Listen.
चैप्टर नहीं पढ़ा
ऐसा टेंशन नहीं है।